So far, we learnt about factors. What are multiples? Multiples, what are called multiples in English, are another important concept. Now, if we take the digit 2, for example, when we place the 2 once, how many do we have here? We have 2. What do we get when we place the 2 for a second time? 1, 2, 3, 4. We get 4. When we place it the third time, we get 6. As we continue placing it in this fashion, the number we get goes on increasing. These numbers are called the multiples of 2. These are multiples of 2. This is what we learnt in multiplication, right? When you place 2 once, it is 2. When you place 2 thrice, that is 2 multiplied by 3, we get 6, correct? Therefore, the different products of the digit 2 are called the multiples. Here, you have to observe that the multiples of any given number are always greater or in an increasing order than the given number. And they keep continuing without an end. They multiply infinitely. Let us look at another example, the multiples of 3. Here is 3. You can place it in groups as well, like 2 groups of 3, 3 groups of 3, 4 groups of 3. The first has 1, 2, 3. The second has 4, 5, 6. The third group has 7, 8, 9. The fourth group gives us a total of 12. Therefore, the multiples of 3 are 3, 6, 9, 12. And does it end here? No, it continues infinitely. 12, then 15. We have learned tables, right? This continues in the same way as tables. How can we show this? Children would have learnt the representational method in the multiplication stage, so there is no need to do it again. But we have to write the multiples. We have 3, 6, 9, 12, 15, and so on to show the infinity. This is the method of writing it. It is written like this in textbooks too. In questions, you might be asked to write 3 multiples of 5. Then you'll have to list 3 multiples of 5. Let us see how this can be represented in a number line. Shall we look at the multiples of 5? If I start here, at this point, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many are there totally now? 5 and 5, 10, 11, 12, 13, 14, 15. We have 5 here also. 16, 17, 18, 19, 20, 25, 30. We have started from this point. So we have 5, 10, 15, 20, 25, 30. Though the number line ends here, the multiples keep continuing. The multiples can also be represented in this way. We learnt about factors and multiples. In order to learn mathematics further in higher grades, for topics like prime numbers or for learning other topics like LCM and HCF, it is very important to learn and have a good understanding of the concept of factors. Without learning the concept of factors, it is not possible to understand the LCM and HCF lessons. Similarly, for the summation and subtraction of fraction numbers, it is important to have a strong base in factors.